Okay, 4-3 right triangle trigonometry. We have been doing right triangle trigonometry. I've just told you it was x, y's, and r's. Okay, now it's going to be opposites, adjacents, and hypotenuse.
Nope.
Okay, so it's going to be the same stuff, just I'm going to call it different. But we were doing, let's go.
Let's go. No, Kale.
Okay, so sine of this angle right here, theta, right here. Okay. So the hypotenuse is always the hypotenuse, yes?
Yeah.
Hypotenuse is always across from a right angle? Yes? Okay, the adjacent and opposite are going to switch. So if we're talking about this bottom, just this bottom theta, where sine is opposite over hypotenuse. So cosecant then is what?
Let's say about
Hypotenuse
over
over opposite, because they are reciprocals of each other. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. If you think back to putting this in our coordinate plane in our circle, x was adjacent, yes? Y was opposite. R was the hypotenuse. So it's no different. I'm just taking my triangle out of the coordinate plane. If you're like me, I draw all my triangles one way, so I still have an X and I still have a Y. You'll draw so many triangles and circles.
I don't like
I can't draw straight lines.
triangles are going to be half circles. Be impressive.
That's up to you. As long as you know opposite means opposite the angle, right? Adjacent means adjacent to the angle. Could I switch this all and name this beta up here? So the opposite then would be there and adjacent would be there. And is the hypotenuse still the hypotenuse? Yes. So when you're doing 30, 60, 90 and 60, 30, 90, do you need two triangles? You need what? One. You just switch angles that you're looking at.
Would there be a thing where you have to find the beta as well?
Yeah.
Or is it all just going to be just theta?
No, it could ask you for both.
Wait, what's theta?
Theta is just an angle. It's just a variable for an angle.
Okay.
Like beta is just like an X or a Y.
You're a beta.
You are the definition.
So it's really important that you know what angle you're talking about and discussing. That's why drawing pictures, because you will have a lot of application problems. That is why drawing pictures is very helpful to the whole situation. Am I good to go?
Yeah, I'm just writing.
Okay. So, the equation of the circle yesterday, wait before you start writing so what you're writing is meaningful. The equation of the unit circle was x squared plus y squared equaled r squared, which was 1, right? That was, please don't do that. That was an equation of a circle, correct? What does that remind you of?
I'd say about Pythagorean theorem.
About the Pythagorean theorem. The Pythagorean theorem and the equation of a circle are exactly the same thing. Okay? The hypotenuse is your radius. Okay? The Pythagorean theorem, the equation of a circle, and the distance formula are the same thing. Okay? It's all the same thing. We also have the hypotenuse squared plus opposite squared plus adjacent squared. That should be a squared, not a 2. Right here. This should be a squared. That is equal. It's the Pythagorean theorem. What? Adjacent is next to whatever angle you're talking about. Now, there is not adjacent to a right angle, guys. You get it? Like the only angles you're finding in a right triangle would be the acute angles, not the right angle. So
Is there such thing as adjacent to an obtuse?
Well, then it would be
there
right
isn't.
angle.
It isn't a right triangle then.
Oh, never mind.
When we have non-right triangles and we go to solve them, we'll be using the law of sines, law of cosines. So if I have that triangle there, that's a 3, 4, and how are we going to find the other one?
By just knowing that's a Pythagorean triple.
It is a Pythagorean triple, but if you don't know what a Pythagorean triple is, you would use the Pythagorean theorem, yes? So 16 plus 9 is 25. Square root of 25 is what? 5. It would do you much good if you would remember some of those Pythagorean triples. It's 3, 4, 5 as long as 5 is on the hypotenuse. If 5 is not on the hypotenuse, do not get tricked that you have a 3, 4, 5. Make sense? Hypotenuse is always the longest side. Anybody know another Pythagorean triple?
5, 12, 13.
5, 12, 13 is another one. Okay, those are the two most common. Okay, so once we have that, it says find the 6 trig functions of theta. So we are looking at theta, right down here. If you look at the wrong angle, are you going to get the wrong opposite? Yes. Okay, so the sine of theta is opposite over hypotenuse. So opposite is 4 over 5. I would abbreviate today. I would do exactly like you did the first day of X, Y's, and R's. I would use O, A's, and H's. What's O?
Opposite.
What's A?
Adjacent.
What's H?
Hypotenuse.
Hypotenuse. Okay, so I did sine. What should I do next? Cosecant. So cosecant of theta is H over O.
I'd say about 5 over 4.
5 over 4. You want to finish the rest of them?
Yes.
Okay, go for it. That is a 4. Sorry, that's a horrible 4. Did you get them all right?
I will.
You will. I don't want to spend more time on that than we have to. I do not want to sit here and shove it down your throat when you're like, I already know this, quit it. Okay. Does it make sense to you, though, that you're ready to start learning that? Okay. Or I'll keep going notes, but I just don't want to spend too much time on them. Can you see the relation between the opposite and the y?
Yeah.
If I put this triangle in a coordinate plane,
The opposite is the
it would be in the second quadrant, right? So this would be my x. This would be my y. So it's my opposite and my adjacent. And my hypotenuse would be my r. So it's all the same.
See, since it's on that side, would it be flipped this way?
No.
No, it would be like this because you always go from the origin out if it's in the coordinate plane. Because remember, we always go to what axis? The x-axis. We don't ever go to the y-axis. So that would be in the second quadrant. Questions before we move on? Okay, find the 6 trig functions for 30, 45, 60. Those are the special right triangles, okay? So this is where I said this is the key to everything other than the quadrantal. So we can draw a triangle. And make it a 30, 60, 90 triangle. Or we can just write 30, 60, 90. Okay? I prefer to write 30, 60, 90. Who said they drew horrible triangles?
Brown.
Okay. I am so OCD. If I do not like how my triangle looks, I will erase it and rewrite it until I like how it looks. Is that a good waste of, like, a good use of my brain energy? No, it is not. So what I do is I use just 30, 60, 90, and I know opposite of 30 is what ratio?
That one.
What is it?
1.
1. So I put a 1 there. Or if I'm using a triangle, I put a 1 opposite of 30. What's opposite of 60?
Square root of 30.
Square root of 3. So I put square root of 3. What's the hypotenuse?
2.
2. So I could put 2. So either one of those you want to use, do it. But by doing 30, 60, 90, did I take having to look at a triangle or make a triangle?
Yeah.
Yes, because opposite is Jason is next to it. Okay, so then we're going to do a 45, 45 triangle. These are the ones that bug me, because if I don't get them exactly the same, I keep rewriting them, and it's a waste
Like
of time.
that. So can you rewrite that one?
No, shush. Okay, so 45, 45,
45.
45.
Opposite of 45, square root of 2.
So I got square root of 2, square root of 2, and
2.
2. Okay, so either one of those that you think that you want to use, go for it and use. But if I have those on my paper, should I be able to do every single angle, every single trig function?
Yes.
Yes. Yes, sir.
So is the hypotenuse always going to be 2?
If you use square root of 2, square root of 2, 2.
Okay.
If you use, like in geometry, I would probably bet you were taught 1, 1, square root of 2.
I don't remember.
Okay. I would assume that you were taught 1, 1, square root of 2, because that's just what they do. And if we rationalize 1, 1, square root of 2, so we multiply them all by the square root of 2, we get 2 on the hypotenuse, the same. I want to tell you, my geometry students, I teach them square root of 2, square root of 2, 2. Just because it makes it easier. Yes, sir.
How did you figure out like the 1 square root of 3, 2?
Those we just know. That's what we've been, like, last week when we had the special right triangles. You just need to know those. Yeah, they're just, you need to know them. If you don't already know them, you need to get them in there. Okay? So sine of 30. So sine is what over what?
Oh.
Opposite over hypotenuse.
Opposite over h. So opposite of 30 is 1. Or you go opposite of the triangle is 1. Hypotenuse is 2. Now I'm going to list these because we have 30, 60, and 45. So what do you want to do next? Cosecant of 30 is hypotenuse over opposite. So that would be 2 over 1 or 2. Cosine of 30.
A over h.
A over h. So it is
Square root of 3 over 2.
square root of 3 over 2. Adjacent is next to it. So adjacent to 30 is square root of 3. Then what do you want to do? Secant.
Secant of
H over A.
30 degrees. That would be 2 over square root of 3.
So 2 square root of 3
So you have,
over 3.
you have to multiply top and
We
bottom.
have to rationalize, so 2 square root of 3 over 3. Are you guys being able to start doing that, like in your head? Like you have 2 over the square root of 3, so you can just do it? Those simple ones like that, I would assume you were. Tangent of 30. Opposite over adjacent.
You have to rationalize that.
So 1 over the square root of 3.
So square root of 3 over 3.
Now, when you guys have your quizzes starting next week on these, I give you random angles and I ask you for the sine, cosine, and tangent. If you leave it 1 over the square root of 3, you miss half a point. Okay? You have to be rationalizing them. And then cotangent. Now, you think you could do tangent on your own, not 45 on your own?
Yeah.
Do you want to do the 60 degrees? Or
If we have to, we will. If we don't have to,
probably just the opposite.
it is.
Same thing.
It's actually what's going to happen when I do 60.
It's all going to be.
It's all the sine is going to be the cosine. The cosine is going to be the
Sine.
sine. That's what's
And
going to
then
happen.
that tangent is gonna be the cotangent.
Yep.
So is there a need to do 60 degrees?
Well, let's do 45 and see if there's a need to do it 60. So everybody do 45s.
Everything.
Do you need help?
Should figure it out.
Okay.
I'll stick to my ears in.
So,
That's better than
did you guys get it? Yes. Did you rationalize correct on cosecant and secant?
that.
Yes?
Yes.
Okay, questions. Is there a need to do 60? Okay, we discussed though what is going to happen with 60.
60 is gonna be the opposite of 30.
Right. On 60, the sine is going to be the sine of 30 is going to be the cosine of 60. The cosine of 30 is going to be the sine of 60. They are co-functions. Okay? Sine and cosine are co-functions. Secant and cosecant are co-functions. Tangent and cotangent are co-function. So the 30 of one, the complements. There's my words I wanted. The complement are 30 and 60 complements of each other.
Yes.
Okay, so the complements of co-functions are going to have the same trig values. So that's why it works.
Sine of 30 is a half, cosine of 60 is going to be a half.
Yes. So like if I told you the sine of 47, I don't know. I'm going to make something up because I don't even know. The sine has to be bigger than a half, right? Sine would be wide, bigger. So let's do 1/5 is smaller than a half.
Oh.
How about 2/3? Okay. So 2/3. So if the sine of 45 is 2/3, so the cosine of, what's the complement? I said 40. Let's do this out in writing so we do it. So if I say the sine of 47 is 2/3. So the cosine of what is going to be 2/3? The complement of 47 is
43.
43. See how that works? Okay, so that happens for every cofunction. So sine and cosine are cofunctions. Cosecant and secant are cofunctions. And tangent and cotangent are cofunctions. I'm gonna run out of room. Can't see my S on functions. So that's why it works that way. And you can really see it with 30 and 60 because you're just taking your triangle and switching sides, right? It's harder to see with something like 47 and 43. And I can guarantee you the sine of 47 is not 2/3, but I just made that up, okay? I swear it's not.
Last school.
Okay, we good? And there's your cofunctions. Cofunctions of complementary angles are equal. I just said that, right? Okay, so sine of 90 minus theta is the cosine. This is technically what I just told you. Okay, so if I take 90 minus an angle, do I get the complement? Do I get the complementary angle? Yes?
Yes.
So all these are just equations of what I just told you. So if that really doesn't make a whole lot of sense, cofunctions of complementary angles are equal. That's what I would write from this.
Not the equations.
I don't know if the equations do you any good. Does it do you any good?
No, they look confusing.
Okay. So if you understand what are cofunctions, sine and what?
Cosine.
Cosine. They have tangent and what?
Cotangent.
Cotangent, secant and
Cosecant.
cosecant. Co-functions. As long as you know that the co-functions of each, sine and cosine, tangent and cotangent, secant and cosecant, they are, and you understand what a complement is. You all understand what a complement is?
Mhm.
The sum is what?
90 degrees.
90 degrees. Okay. You're going to have some problems. It's going to say the sine of 47 equals the cosine of 43. You have different problems like that. They will have some that look like this, but what's all this saying right here? 90 minus theta, it just gives you the what?
The cosecant.
Just to give you the complement. That's all that is. So if you want to write the equations down, that's fine, but you need to know that 90 minus theta is finding a complement. And I will always show you how the book shows you because it's important to be able to decipher and learn from a textbook because you guys will have to do it as you move through your academic careers.
College, they don't do this?
What?
College, they don't do stuff like this?
Oh no. College, they tell you co-functions. They give you that one line and that is it. You will have to look through your book and learn. Nope.
Do you have dual credits?
Yes. It is. We have it all. I figured we would get through this maybe tomorrow. If everyone is here, I would like to do everybody at one time. So, are we good on this slide, guys?
Yeah.
Okay. I do have it. It's right here. We have until February 18th to get you enrolled. Okay, so these are identities. And this is where we're going to stop today because I don't think you're going to use them. But I want you, before you start writing, and I'm not going to talk why you write, but so listen, please. Reciprocal identities. Did we already talk about that sine and cosecant were the reciprocals of each other?
Yeah.
Yes. Okay, so this says sine of theta is 1 over the cosecant. So cosecant is 1 over the what? Sine. Just meaning they are what? Reciprocals. You already know them. You've been using them, correct? So don't let that bother you. 1 over something just means it's reciprocal, correct? Okay. Now, I haven't explicitly said it, but we did tangent was y over r, or opposite over adjacent. Well, what's y?
Y is
Sine. What's x?
Cosine.
Cosine. So if I took my sine over my cosine, would I get my tangent every time?
Yes.
Yes. You've done it already. I just didn't put words to it. Yes.
I don't know, but I just thought it sound a little confused more people when I say it. But for the reciprocals,
Mm-hmm.
sine,
Sine.
and then the cosecant.
Mm-hmm.
So those are reciprocals. But for the last part, it was sine and cosine were complementary. So
Well, they were co-functions.
Okay.
The co-functions, they're complement angle. Sine and cosine are co-functions. So they're complementary angles. Those were equal.
Okay. So then that is something. I don't know. Never mind.
Okay. The way I remember that sine and cosine are co-functions, it says it in the name. Sine and cosine are co-functions. Okay? And I pair sine with cosecant because I have sine starts with an S, cosecant starts with a C. Cosine starts with a C, secant starts with an S. So my pair has to have an S and a C.
Except for tangent.
Well, yeah, but those aren't the ones you confuse. People confuse sine and cosecant because they want to put sine and secant together, and cosine and cosecant, and it's opposite. Okay? So now if tangent is sine over cosine, then cotangent would be what? Cosine over sine. Okay? The last ones are the Pythagorean. I'm pointing out Pythagorean. Okay, what's the Pythagorean theorem?
A squared, B squared equals C squared.
Okay, so we should have some squareds in there going on, right? So we have sine squared, which would be your your y, yes,
Y squared.
plus
X squared.
x squared for cosine equals 1. which is your unit circle. Do you see that?
Yeah.
Okay, so sine squared theta plus cosine squared theta equals 1. Now the next ones we will build tomorrow so you can see how they happen, but I want you to write them down. I have 1 plus tangent squared equals theta. 1 plus tangent squared of theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared of theta. So I'm going to quit talking, but I am going to tell you these are non-negotiable. You have to use these and know them. Frontwards, backwards, upside down. Okay? Do you already know the first 6?
Yeah.
Yes. The second 2 make sense, right? So right now you will not be using the Pythagorean today, but we are going to work with them tomorrow. So if we write them down today, then we can dig into them tomorrow. Oh, and can I stop you real quick? Real quick. I said sine squared theta. Sine squared theta means sine of theta, the answer squared. Does that make sense? Sine is a function. You can't literally square a function, can you? No. So you would take sine of the angle, you'd find it, and then square your answer. So that's what that note is.
So like it would be 1/2 squared.
So 1/2 squared would be 1/4.
Makes sense. I feel like the bottom part was all we had to really write down.
Well, all of it is you will need to know. We will be doing proving identities, and so it would be a good idea for you to put those in a place where you know they're at so you can learn them. And I'm going to tell you guys, it is a struggle for people to, you need to find a method to learn them, really learn them, not always be looking at your paper. Because I told you right now, I'm not giving them to you on anything. So you have to know them. And there are other identities we will learn that I will give to you because you just need to know how to use them. But these you need to know.
So should we write down, like, keep it a separate piece of paper?
I would put them in your notes and then maybe write them on a note card or something to have it in the front of your notebook. That would probably be what I would do. Like I said, in calculus and things like that, you will use other identities and you'll need to know how to use them. But it is an expectation that you know these. This is not this is a non-negotiable that people will say, oh, we'll give you a cheat sheet on these identities. They will not. You'll have to just be able to use them randomly. I think on the second week of school, I had a problem in calculus that they had to remember that the sine of 60 was square root of 3/2. So these things are needed. When you guys are finished, I want to do one example with you. I don't think we did one, but it wasn't phrased in the way that I would like it to be phrased. Does that make sense? So disregard, well, actually don't discard that. Okay, sign. Find the 6 trig functions of this. Okay, I have sine of theta equals -7/10. So I probably should draw myself a triangle, yes?
Yeah.
Okay.
Well, you already got signs, so you don't
And I put a theta where I'm talking about that angle. I don't know what theta is, right? Actually, I shouldn't probably draw my triangle there. Where's my triangle? Where's it at?
On a unit circle, on a graph, on a graph.
What do you notice about the sine?
It's negative.
It's negative. Oh, but they're not going to give you any negatives today, so I'll be nice. I'll take away the negative. Never mind. That's for another day. Okay, so if it was -7/10, it'd be a negative, sine is opposite, right? It'd be a negative y. So that would be in the third or the fourth quadrant, wouldn't it? So you'd have to go from there. So this is theta.
Go home.
Where does 7 go?
7 goes on the opposite of theta
How do you know that?
because it's on top
Because sine is opposite over what?
over.
Hypotenuse. How are you going to find the adjacent?
Well, c
Divide
squared
by zero.
equals c squared, and then you would subtract over. No. Yeah, what?
Because we have the Pythagorean theorem, yes, that says a squared plus b squared equals c squared. And I have c squared, don't I? Or I have c. So 100 equals, can I just put x squared
Yeah.
plus 49?
So subtract the 49.
Where did I get 100 and where did I get 49?
7 squared and 7 squared.
Okay, so minus 49. So 195, 51. Is that right?
Yeah.
Okay, x squared. Now what?
Take square root of both sides.
Take square root of both sides. Now,
That is not nice.
if I take the square root of both sides, it's plus or minus, correct?
Yeah.
Okay, I pick plus or minus depending on what quadrant I'm in. If this was the hypotenuse, it would always be positive, correct? Hypotenuse is a radius. Can a radius ever be negative?
No.
No. So if this was a hypotenuse, it would always be the positive. This is not a hypotenuse, but I'm pretty sure your directions say you're in the first quadrant. Okay, so it's not going to be the negative, it's going to be the positive. So it's the square root of 51. Now that I have that, can you find your 6 trig functions? Okay,
I guess.
I wanted to do the setup of this problem to make sure you understood what was going on. Okay, so do the 6 trig functions real quick, and I'll do them, and we'll get the same answer, right?
Should be.
Hopefully.
So it would just be sine of sig
Theta.
theta, yeah.
I think you take a sick day.
So still sign homework.
Oh, this is easy.
Not really. You don't have to do much with it. Why did you think it was evil?
Oh, the secant.
Yeah, but you were still not doing any, you don't have to reduce or anything.
Yeah, I overthought it.
How did it go? Okay. So they'll give you, and I did assign every problem. These are problems will take you a minute, but should they be taking you an overabundance of time?
Yes.
No.
Hour and a half.
The reason I did assign everything between 6 and 22 is by the time you're done, I want you just saying sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. I want it in your brain before we start having to use it for things, okay? Questions?